Hello, in this math video, I will do a GED math video regarding solving rational expressions. Okay, so as you recall, a rational expression is basically a fraction, uh, qx over qx. So if you have a fraction, you are dealing with rational expression. Okay, so there's some keynotes I want to go over before I do our three problems. So go ahead and get out your notebook and write down these three notes. So the first note is when adding or subtracting polynomials, make sure to find the common denominator. Okay. Okay, so that's keynote. And then the other one note is when subtracting polynomials, make sure to distribute the minus sign. That's something very easy, and a lot of people make mistakes. If you have a minus, like in the first one right here, if you have a minus, make sure you distribute that minus. Okay. So, yeah, those are pretty much it. Oh, you're gonna need to know your factoring rules. So if you need a refresher on factoring, check out the supplementary videos. Okay, I'm going to do question one, so I'm going to stop right. I'm going to clear it. Okay, so question one says, which of the following is the results of uh, x squared plus 2x minus 8 all over x squared minus 4 minus x plus 3 over x plus 2? So as you can see, we have two rational functions and we are subtracting two rational functions. So what we need is a common denominator. So let me write it out again. We have x squared plus 2x minus 8 over x squared minus x plus 3 over x plus 2. Okay, so it says that if you are adding or subtracting, we're definitely subtracting because it's a minus. You need to first find a common denominator. So how do you find the common denominator? If you look at the denominator first, so we have an x squared minus 4. Think of this as one whole term or parentheses x squared minus 4. And then you have this other x plus 2. Think of this whole term as one whole term or parentheses x plus 2. So how do you find your common denominator? So it's a little bit tricky at first. You need to make sure it's in the most premise form or in the most factored form. So look at the bottom. X squared minus 4. Ask yourself, is it in the most premise form or in the most factored form? No, right? This is a perfect square. It will be factored out as x plus 2 times x minus 2, right? I think I went over a perfect square rule in one of the videos, but there is a there is a video regarding factoring perfect squares on the supplementary video. So if you need a refresher, go ahead and watch that video. But I know it factors out as x plus 2 and x minus 2 because let me just quickly review this. Perfect square is a squared minus b squared, and that equals to a plus b times a minus b, right? So what we have right here, x squared minus 4, looks like the left. What we got to do is make it look like the right and figure out our a or b. That's always the tricky part, figuring out your correct a, b. So my a, so what number when squared gives you x squared, or in our case, what letter? So it would be x. And my b, what number when squared gives you 4? Positive 4. Don't worry about the minus 2. Okay. And then I just make it, once I know my a and b, I just make it look like the right, a plus b times a minus b. And so it's x plus 2 times x minus 2. Okay. So yeah, if you need a little bit more help, there is a supplementary video. And then on this side, we have an x plus 2, right? It can't be factored, right? It's in the most primest form. It cannot be broken down. Okay. So once you have it in the most primest form, right, can't be factored anymore. What you want to do is look at the base. If you have a repeating base, pick the one with the highest power. If you don't have a repeating base, just bring it down. So what do I mean by base and repeating base? So look here, x plus 2 is a base, right? You could think of it as one term, and it can't be broken down. Do you see another base of x plus 2? Yes, I see it right here. It's really x plus 2 to the power of 1 if you really see it like that. So I do see it here, and I see it here. Now, they say if you have a repeating base, pick the one with the highest powers. Since they're both to the power of 1, you're just going to say x plus 2 parentheses or x plus 2 to the power of 1. It's the same thing, right? Now, what about this other base of x minus 2? Do you see it as a repeating base? No, I don't see it anywhere else. So bring that down. Okay, so this is your common denominator. Do not FOIL it out, leave it as it is, because you'll see what I mean. Okay, so if you want, you uh, if you know your common denominator, you could just on the bottom you could just put your common denominator, right? X plus 2, x minus 2. Don't worry about, you'll see. Now over here, x plus 2, what are we missing to find our to get our common denominator? Well, we already have an x plus 2, so we're missing an x minus 2. So you're going to multiply top and bottom by x minus 2. And then on the left side, it looks good. We have an x plus 2 and an x minus 2, so that's our common denominator, so we don't have to multiply anything. Okay, so all we got to do is fix the numerator because the denominator is always going to be your common denominator. Okay, so we got to just don't worry about the bottom anymore because the bottom is just your common denominator, which is x plus 2 and x minus 2. All we got to do is fix our simplify our numerator. So let's fix this part. We got to do some algebra. We got to FOIL this out and then distribute this minus. So go ahead and FOIL this out, clean it up, then distribute this minus. So go and FOIL it out. What is x times x? X squared. What is x times negative 2? Negative 2x. What is 3 times x? 3x. What is 3 times negative 2? Negative 6. Let's see if I can clean this up a bit. Yes, I can. I can clean up the negative 2x and 3x. That is going to be positive x. And then you have this minus 6. And then you may distribute this minus. So that's going to be negative x, negative x, and then positive 6. And then I haven't done anything with this, so just bring it down. And then it's all about collecting like terms. So what do you see can you collect or what can you cancel? It looks like the x squared cancels, right? You have an x squared and negative x squared that cancels. And then you can collect this 2x and this negative 1x, which is just positive x. And then you can collect your constant, negative 8 and positive 6. What is negative 8 and a positive 6? Negative 2. If you want, you can write this out as one parentheses. Okay. And then the fun part, do you see anything that cancels? Or do you see that's the same, exactly the same top and bottom? Yes, I do. I see the x minus 2 and x minus 2 that are the same top and bottom, so you may cancel that out. And what happens is this doesn't become 0, it just becomes an invisible 1. So you're left with 1 on the numerator, and then on the bottom, you're still left with this x plus 2. Okay, you could put parentheses if you want, you don't have to. So it looks like it is going to be letter A, right? 1 over x plus 2. Okay. So let me recap what I did. Um, when you're adding or subtracting rational functions, you need to find the common denominator. So to do so, you look at the stuff on the bottom, and then you make sure it's in the most primus or in the most factored form. X squared minus 4 is a perfect square, so it can be factored out as x plus 2 and x minus 2. This x plus 2 is in the most primus form, so you don't have to worry about that. And then what you do is look at the base. If you have a repeating base, which we do, we have a repeating base of x plus 2, or x plus 2 to the power 1. Pick the one with the highest power. If you don't have a repeating base, bring it down. So this is how I got my common denominator as x plus 2 and x minus 2. Once you know your common denominator, you can put that stuff on the bottom. And then it's the numerator that requires some algebra. So over here on this side, we said that if our common denominator is x plus 2, x minus 2, it looks like it was missing an x minus 2. So that's why I multiplied top and bottom by x minus 2. Okay. On the left side of the rational expression, it wasn't missing anything. It was x plus 2 and x minus 2. So we are good. We didn't have to multiply anything by this, but you did have to bring it down. Then what I did was I FOILed this out. This part, x plus 3 and x minus 2, FOIL it out, clean it up. Then I didn't forget to distribute this minus, right? If it was just plus, you didn't have to do anything else. So I distributed that minus, and then I brought this down because this is still part of our problem. Clean it up, collect by terms, and that's how I got x minus 2 on the top. And then on the bottom is just your common denominator, x plus 2 and x minus 2. And do you see anything that cancels? Yes, I do. I see that x minus 2 cancels. So you're left with 1 or x plus 2. Okay. I know it's a little bit work, but practice and makes perfect. Okay, let's move on to question 2. Question 2 says, identify the correct simplified form of expression. So we have these two rational expressions. We have 2 over x plus 2, and then 3x over x squared minus 4. So just like the other one, we need to find the common denominator. So how do you find the common denominator? You look at the number, you look at the stuff at the bottom. Here, let me write this out. I don't know. I don't know if you can see this better, so I'm just going to write it out. 2 or x plus 2 plus 3x over x squared minus 4. Okay. So we define a common number. You look at the stuff at the bottom. So our bottoms are x plus 2. And you could think of x plus 2 as one term. And then here you have x squared minus 4. Okay. Is this in the most primus form? Can it be factored a bit more? Well, I know that x plus 2 can't be broken down, but I do know x squared minus 4 is a perfect square, right? And it factors out as x plus 2 and x minus 2, right? Because what is the perfect? Let me go over this real quick. Perfect square is this, x squared minus b squared equals a plus b times a minus b, right? And then what we have is we have it on the left, right? X squared minus 4 looks like the left side of the rule. Got to make it look like the right, and we got to figure out our A and our B. So my A value is Can you think of a number? I mean, not a number, but in this case, a letter. Can you think of a letter square times itself twice gives you x squared? Yes, it's x. And then our b. Don't worry about the minus. Can you think of a number when squared gives you 4? Positive 4? Yes, it's 2, right? 2 squared gives you 4. So that's the hard part. And then once you know your A and B, just make it look like they're right. So that's how I got x plus 2 and x minus 2. Okay, so now let's look at our base. If you have a repeating base, pick the one with the highest power. If you have a non-repeating base, just bring it down. So let's look at the base of x plus 2, x plus 2 to the power of 1, right? Do you see it? Do you see it anywhere else on the bottom? Yes, I see it here, right? So they're both to the power of 1, so you don't have to stress about that. So it's just going to be x plus 2 or x plus 2 to the power of 1. And then the repeating base of x minus 2. I don't see it repeating, so I'm just going to bring it down. Okay, so that is my common denominator. So if you want, you could put the bottom as x plus 2 and x minus 2, because the bottom will always be your common denominator no matter what. It's the numerator that requires a little bit work. Okay, so let's look at the right side. Our right side is good because it has our common denominator of x plus 2 and x minus 2. So don't worry about that. So you don't have to multiply anything top and bottom. The left, I mean the left side, you are missing an x minus 2, right? So you do gotta multiply top and bottom by x minus 2. Okay. Don't worry about the denominator. The denominator will always be your common denominator. So don't worry about any of this stuff. The top is what you need. So on the top, we're going to do some algebra. You got to FOIL out this. You got to multiply 2 times x minus 2, and then you got to add that 3x. So go ahead and FOIL that out. So it's going to be 2x. 2 times negative 2 is negative 4. And then you have this plus 3x. Then it's all about collecting like terms. So what can you see that you can collect? You can collect the 2x and the 3x, just 5x. And then you have a minus. Do you see anything you can cancel? So do you see anything that's the same top and bottom? No. None of these are the same base, so nothing cancels. So it looks like it might be letter A, right? 5x minus 4. X plus 2, x minus 2. Letter A. Okay, not too bad. Okay, let's look at question 3. Which of the following is a result of this? So it's question 3 is just like question 1. You're subtracting rational functions. So what you need to do is, here, I'll write it out again. I don't know if you can see it. So what we got to do is find our common denominator. Common denominator. Let's see here. So look at the bottom, and make sure it's in the most primitive form. So x minus 3 is like one term, or it's like 6 minus 3 is a part 1. Can it be broken down or factored? No. What about x over here, x squared minus 9? Is it in the most primitive form? Can it be broken down? Yes, it's a perfect square, and it will be factored out as x plus 3 and x minus 3, right? Okay, if that's the case, then what you got to do is look at the repeating base. So here I have an x minus 3, and I also have a repeating base of x minus 3. They're both to the power of 1, so it's just x minus, and then x plus 3. I don't see it as a repeating base, so I'm just going to just bring it down. Okay, so that is my common denominator, so you can put that on your bottom automatically. The numerator, the top part is where you need some algebra. So on the right side, we're good. It has a common denominator of x plus 3 and x minus 3. That's perfect. We do not need to multiply anything top and bottom, right? The left side, what are we missing as our common denominator? We have an x minus 3. The only thing we're missing is this x plus 3. So go ahead and multiply top and bottom by x plus 3. Okay, so you got to do the numerator. The bottom is good. The bottom will always be your common denominator, so don't worry about the bottom. Just worry about the top. So FOIL out this 4, so that's going to be 4x plus 12. And then you remember what we said before, if you have a minus, you're going to have to distribute that minus. So think of this as an invisible -1, if that makes it easier. So FOIL out that -1, so that would be -2x. And then this would be -1. Okay. And then it's all about collecting like terms and canceling. So what can you collect? A 4x and -2x, which is positive 2x. And then a 12 and a -1, which is positive 11. Okay, do you see anything that's the same top and bottom? No, nothing cancels, so it is what it is. So it looks like, yeah, it looks like C, right? 2x, oh no, 2x. It's 2x plus 11, so it's not C, it's B, right? It's 2x plus 11, x plus 3, x minus 3. You could switch these two around, it doesn't matter. Yeah, so it's B. Okay, I'm gonna check my results. Perfect. Okay, so this was a small taste of solving rational expression or adding, or also known as adding or subtracting polynomials. So this will definitely come up on a test. This will definitely show up again when we do an actual practice exam. Okay, so these are just practice exercise. I'm going to stop here.